In this video, I'm going to discuss a solution for your problem 17 of homework number 2. This is an extension of the previous question. I completely discussed that question also. There's a separate video explaining that. So if you didn't see the answer for that question yet, you may go back and watch that one and come back here. So problem 17 is, assume that there are 5 difficult MCQs in your final Stat 325 exam. Well, of course, in your final exam, there will be 12 multiple choice questions. You're going to assume that 5 of them are difficult, which means a student taking that exam, we are going to assume that the student doesn't know the answer for 5 of those MCQs. You're going to randomly pick an answer for each of those. Still, the probability of your random answer being correct is 1/3. You don't know the correct answer. Still, you're going to pick a random answer for each of those 5 questions. Since each MCQ has 3 choices, the random answer being correct has a probability of 1/3. Since this is similar to a repeated random experiment with 2 possible outcomes in each step, of course, the random answer is the random variable. There are only 2 possible outcomes. The answer could be correct or it could be incorrect. Therefore, it can be modeled using the binomial distribution. So please pay attention to the given distribution name. For all the questions of this type for your class, the distribution will always be given to you as a part of the question. All right, now we can answer the questions. Part A, what's the random variable x described above? Write the distribution of x using the standard notations. Clearly, the random variable x should be the random answer. That x follows a binomial distribution. So you write it as x is distributed binomial, and for the binomial distribution, there are 2 parameters, n and p, where n is the number of trials and p is the probability of success. For this question, your n is equal to 5. Because there are 5 difficult questions. So it should be 5, probability of success is equal to 1/3. Please remember, whenever you have a binomial random variable, the standard notation is x is distributed b n, p, where n is the number of trials and p is the probability of success. Let's go to part B. What are the mean and the variance of the number of possible correctly answered MCQs out of the 5 difficult MCQs? That means I simply need the mean and the variance for the binomial distribution. So how did we define the mean for the binomial distribution? For the binomial distribution, we defined the mean to be equal to n times p. For this example, n equals 5, p equals 1/3. So it's 5 times 1/3, which will be simplified to 5/3. If you don't like to keep fractions as your answer, you can directly write down the decimal answer, which is 1.6667. We should also find the variance. How did we define the variance for the binomial distribution? Variance for the binomial distribution was defined as n times p times 1 minus p. Since n is equal to 5 and p is equal to 1/3, it's going to be 5 times 1/3 times 1 minus 1/3. When you simplify that, you get 10/9. If you don't like fractions, once again, you can keep the answer as decimals. So it's going to be 1.1111. All right, let's go on to part C. You need to see your chances of getting 3 correct answers out of the 5 difficult MCQs. What is the probability that exactly 3 of the 5 MCQs would be correctly answered? That means I need x to be exactly equal to 3. That means I need to find the probability that x is equal to 3. So how do you find that probability? Well, of course, we have to use the calculator. You don't need to go for the equation because the equation is difficult. And in your calculator, of course, we will have to go to distributions. What function should be selected? Remember, this x random answer is a discrete variable. It can only take one of the two possible values, correct or incorrect. Therefore, it is a discrete random variable. For any discrete random variable, that x being equal to a given value may or may not be 0. Therefore, we have to find that value. The distribution we need is the distribution PDF. Remember, we use PDF only for discrete random variables. Since the distribution is binomial, we are going to need binomial PDF. Alright, you need to go to the calculator, go to distributions, second variables, that's where you have distributions, and then you need to scroll down until you see binomial PDF. You can see binomial PDF under A. Select that function. Please always read the function that you selected. You should see it is binomial PDF, because in case if you made a mistake and selected binomial CDF, the inputs are going to be exactly the same. However, your answer is going to be incorrect if you selected binomial CDF as the function for part C. Alright, so make sure that you selected binomial PDF, and then you need to define the trials. Trials is equal to n, which is equal to 5. And then P, the probability of success, which is 1/3. The x value. The x value is the value right here, which is equal to 3. Select paste and hit enter again. Then you can see that your answer is equal to 0.1646. Alright, let's go to part D. What's the probability that 2 or less than 2 MCQs out of the 5 difficult MCQs would be correctly answered? That means I need the probability that x is less than or equal to 2. Well, it is a cumulative probability. Therefore, the distribution that you should use at this time is binomial CDF. Alright, let's go to the calculator. Go to distributions, second variables, and scroll down until you see binomial CDF. It's given under B. Select B, binomial CDF, hit enter. Once again, check if you have selected the correct distribution for this question. You shouldn't select binomial PDF for part D. For part D, you should select binomial CDF. Alright, and then you can provide the inputs. First, the number of trials, which is n. N equals 5. P, probability of success, which is equal to 1/3. And then the x value. For this question, the x value is equal to 2. And then select paste and hit enter again. Then your answer should be equal to 0.7901. Alright, let's go to part E. What's the probability that 3 or more than 3 MCQs out of the 5 difficult MCQs would be correctly answered? That means I need the probability that x is greater than or equal to 3. Please remember that x is a discrete random variable. So, can you find the probability x greater than or equal to 3 directly and only by using the calculator? Well, we cannot do that. For a discrete random variable, for a right-hand probability of this nature, we have to use a specific equation. So what is that equation? If you have to find a probability that x is greater than or equal to k plus 1, this is going to be equal to 1 minus probability x less than or equal to k. Now, for this example, we know that k plus 1 is equal to 3. Therefore, k should be equal to 2. Therefore, on the right hand side, we are going to write it's 1 minus probability x less than or equal to 2. Of course, this value, probability x less than or equal to 2, was found in the previous step. It was found to be equal to 0.7901. Therefore, we can straight away use that value. Therefore, this is equal to 1 minus 0.7901. This will be simplified to become equal to 0.2099. All right, that's a complete answer for problem 17 of your homework number 2. Thank you.